All right, let's talk about a skill that can absolutely make or break your system design interview, back of the envelope estimation. As your coach, we're going to master this today. This is the art of looking at a huge, fuzzy problem and, in just a few minutes, sketching out the numbers that will guide your entire design.
And there's no better way to start than with this quote from Jeff Dean at Google. The key phrase here is good feel. This isn't about getting a perfect, precise answer. It's about building an intuition fast. It's about figuring out what's even possible, where the real challenges are going to be, and what truly matters in your design.
So, you might be wondering, when an interviewer hits you with a question like, estimate Twitter's storage needs, what are they actually testing? It can feel like you've been ambushed with a math problem, but I promise you there's a much bigger game being played.
Here's the secret. They care way more about how you get to an answer than the answer itself. The process is everything. They want to see how you deal with ambiguity, how you break down a massive problem into small, manageable chunks, and how you can clearly explain and justify your assumptions. It's your thinking that's on display here, not your arithmetic. So here's our game plan. First, we'll cover the fundamental numbers you absolutely have to know by heart. Then we're going to walk through a real-world example step by step. And we'll wrap up with some crucial tips to make sure you nail this every time.
Okay, let's dive in and build that foundation. To be fast and confident with these estimations, you need the right toolkit. And in this case, your tools are a handful of key numbers that need to become second nature.
It really all boils down to three areas: powers of two, so you can talk about data size; latency, so you understand speed; and availability, so you can frame reliability. So let's start with the absolute bedrock of it all, the size of data itself.
Now, I know this looks basic, but trust me, every single calculation for storage or bandwidth starts right here. You have to be totally fluent in this. You need to know the difference between a gigabyte and a terabyte without even thinking about it. Knowing that a petabyte is 1,000 terabytes, that's just non-negotiable. Okay, so once you've got a handle on data size, the next critical piece is data speed. And when we talk about speed, we're really talking about latency. Getting a gut feel for these numbers is what separates a good design from a truly great one. And to put this in perspective, the scale here is just mind-blowing. Grabbing something from the CPU's L1 cache, that takes about a nanosecond. But reading from a spinning disk, that's in milliseconds. That is 1,000,000 times slower. It's like comparing the time it takes to blink to the time it takes to fly across the country. That massive gap changes everything about your design. This chart really tells the whole story. Just look at the progression. See how fast memory access is? We're in nanosecond territory. But then, bam, look at the huge jump when you have to go to disk. And then the network, a round trip across continents, can take 150 milliseconds. That's 150 million nanoseconds. Your CPU could have done literally millions of operations in the time it took for that one packet to come back. So, what does this all mean? It gives us some dead simple rules of thumb. Rule 1, memory is your best friend. Rule 2, avoid hitting the disk if you can possibly help it. And check this out. See how fast compression is? It's almost always cheaper to spend a few CPU cycles compressing data than it is to send it raw across the internet. These are the intuitions that need to fire in your brain under pressure. Okay, so we've got size and speed. The final piece of our foundation is reliability, or what you'll always hear called high availability. This is just a way of measuring how good a system is at, well, not falling over. And we usually talk about it in nines, like 3 nines or 5 nines of uptime, something that's often guaranteed in a contract called an SLA. And this is where those nines get real. 99.99% availability sounds amazing. But look, that translates to almost 9 hours of total downtime in a year. Your users will definitely feel that. But just push to 4 nines, 99.99%. And suddenly, you're at less than an hour per year. That's a huge difference. This is the math you'll use to justify spending money on things like extra servers and failover systems. All right, theory time is over. We've got our foundational numbers for size, speed, and reliability. Now it's time to put them to work. Let's get our hands dirty and walk through a classic system design problem, exactly like we would in a real interview. So here's the prompt. Estimate the queries per second, QPS, and storage requirements for Twitter. Notice how open-ended that is? That's the point. Our job is to take this big, ambiguous question and create a logical, structured answer. The very first thing you do, always, is state your assumptions. You're not expected to know these numbers off the top of your head. The key is to make some reasonable guesses and say them out loud. This turns the interview from a quiz into a conversation. The interviewer can then say, yeah, that sounds good. Or actually, for this problem, let's assume this instead. So for our walkthrough, these are the assumptions we're going to run with.
Okay, assumptions are on the table. First goal, let's figure out the QPS for new tweets. The plan is pretty straightforward. First, we'll find our daily active users, the DAU, and from there, we can work out the average and, more importantly, the peak traffic.
So let's run the numbers. We assumed 300 million monthly users, and that half of them show up every day. So 300 million times 50%, that gets us to 150 million daily active users. Easy enough? Now we can use that DAU number. We've got 150 million users posting 2 tweets a day. To get that down to a per second number, we just divide by the total seconds in a day. And by the way, just memorize this number. It's 86,400. You'll use it all the time. A little bit of math, and that lands us at an average QPS of around 3,500.
But here's the thing. You never build a system for the average load. You build it for the peak. A really good rule of thumb is to assume the peak is double the average. So we'll double that 3,500 and plan for a peak QPS of 7,000. That's the number that tells you how many servers you need.
Okay, traffic is covered. We have our peak QPS. Now let's switch gears and figure out the second part of the question, storage. How much disk space are we going to need for all the photos and videos getting uploaded? We just go right back to our assumptions. 150 million daily users, posting 2 tweets a day. We assumed 10% of those tweets have media. And a good guess for an average file size is 1 megabyte. You multiply all that out and you get a pretty big number, 30 terabytes of new storage every single day. But we're not done yet. Our assumption was that we need to store data for 5 years. So we take that 30 terabytes a day, multiply it by 365 days a year, and then multiply that by 5 years. And the final number is just staggering, about 55 petabytes. And that's how fast a simple feature can scale into a massive petabyte-level problem. So there you have it. That's the framework. Get your foundations right, then apply them logically. To wrap this up, I want to leave you with just a few final tips that will make sure you absolutely crush this part of the interview. Tip number 1, and please burn this into your brain, this is not a math test. Nobody cares if you can divide weird numbers in your head. They care about your logic. So round your numbers, be aggressive. Instead of 99,987, just call it 100,000. It makes the math a breeze, and it gets you an answer that's good enough to make smart design choices. Tip 2, and I know I'm repeating myself, but it's that important. Write your assumptions down. Put them on the whiteboard. It shows that you're thinking clearly, it keeps you from getting lost, and it gives the interviewer a chance to jump in and guide you. It makes the whole thing feel collaborative. And tip number 3, this one's so simple, but it will save you. Always, always, always label your units. Is that 5 kilobytes or 5 megabytes? The difference is 1,000-fold. Writing 5 MB removes any doubt and shows that you're being careful, even when you're moving fast and approximating. And finally, the most important tip of all, you have to practice. You just do. The only way to get comfortable with this is repetition. So pick your favorite apps, Instagram, TikTok, YouTube, and just run the numbers yourself. You have the framework now. The more you do this, the more it becomes pure intuition, and that's the real point. This isn't just some interview trick. This is a core skill of every great engineer, the ability to see the true scale of a system before a single line of code has even been written.